AI. It is very important one, neuromorphic computing. It is one of the latest technology where it acts as a new paradigm for artificial intelligence. So, what is the main reason of using this one? It is energy efficient, where it supports adaptive intelligence. This addresses limitations of traditional computing architectures. So, traditional computer architectures like so many proposed models are there, like machine learning, so supervised learning. So, in real time, it acts as an important one. So, next one, how it acts as energy efficient. It gives high bandwidth that supports the traditional CPU and GPU space. It is one of the hardware acts like this one. It's a sample diagram shown here. So this is one of the critical need for efficient edge. And also AI plays an important role here. So next, the brain nature's ultimate supercomputer. So it is one of the highly efficient which provides 100 billion neurons, and it supports the parallel processing and complex computations. So it supports trillion synapses, and also it processes information with a high bandwidth of data. So what is neuromorphic computing? So the main motto of using this neuromorphic computing is brain mimicry, in-memory compute, event-driven spikes, massive parallelism. All this is related to the brain structure in hardware, and it is a novel computing architecture. So each and everything can be treated as the one of the process. And next, it supports the parallel activities where it can process the large information. So next one, what is neuromorphic hardware? This is a basic information which supports the more data, where modern architectures are there here, and here it acts like one chip which supports with the unique capabilities. Next, spiking neural networks. So there are some algorithms also discussed here: discrete spikes, event-driven, temporal encoding, local learning. Okay, and here each one is having their own significance. First, what is encoding? It provides a temporal information, and this includes rate and latency coding. And local learning is one of the important one, which acts like a HTTP, where it is related to the spike tendency and parallel with parallel processing. Next, what are the important applications and impact on AI? Edge AI, real-time response, continuous learning, and ubiquitous intelligence. So everything is treated here in the real-time scenario, which provides the real-time response. Okay, and it is one of the continuous learning that is made possible with the entire one. And ubiquitous intelligence, where you are going to act as smart as it is, and you are going to diagnose it, and it creates a new era of intelligent system. Next, what are the advantages? Energy efficiency, low latency, continuous learning. Next, resizing. Because it measures the all resources, and here these three play an important role in the neuromorphic AI. Next, challenges and the role. It is program complexity, hardware availability, training data, bridging disciplines. This five plays an important role here in AI. Okay, every time you have to train the data, and you are going to maintain proper discipline, right? And it measures, it provides all hardware, and also it increases the program complexity. Next, Here it is going to predict some data nearly 1.4 billion by 2027. Okay, and this is one of the important thing you are going to understand the same traditional AI and neuromorphic system. Here it consumes lot of power when compared to the traditional AI, where neuromorphic system shows some progress. And here how SNL plays an important role, spiking neural networks. So first one here is just one second. So biological inspiration, event driven and temporal encoding. So these three play an important role that acts as the core paradigm. Here it is communicate via spikes which provides a biological neurons. And the next one is event driven. Some action performed can be treated as a spike to save energy. And what is a temporal encoding? And here it is going to consider the spike. It is crucial for encoding, and you are going to learn some data. Next, here one of the important algorithm used is spike timing dependency plasticity, STDP, which is one of the important one. The main purpose of this is to provide initial unsupervised learning, and in real time you are going to provide some online learning to save some time. That's why you are going to provide pre-synaptic spike and post-synaptic spike. See, the main purpose of this is to provide neuron, whereas post-synaptic spike is to provide target neuron. This is the basic information you should put in mind. And next, second one is reservoir computing. How reservoir computing works? It was a high dimensional recurrent neural networks, and also it acts as a liquid state machine to apply to the SNN. Okay, liquid state machine plays an important role in addition to the previous one, and this is the main core of this input signal. And next, dynamic reservoir and readout layer. Next, this is the basic examples: Intel Lohi, IBM TrueNorth, BrainChip. Okay, each one is having their own significance to provide some data. Then some more points are there. One time I am going to schedule one more presentation regarding to this one. This is the basic information, and thanks audience for encouraging me the first time this live stream. I hope this video helps you a lot. Okay, and many more presentations will be done shortly with more examples. And please put like, share with others, and ask them to subscribe. Okay, thank you.